The Venusian Paradox, day versus year in the modern discourse on celestial mechanics and planetary behavior. The case of Venus stands as a fascinating anomaly. While students of astronomy may or may not dwell deeply on Venus's apparent color or surface conditions in their elementary education, one celestial peculiarity of Venus often captures the imagination of anyone who stumbles upon it. This peculiarity is, intriguingly, the fact that a day on Venus is longer than its year. The rotational period is defined as the time it takes for a planet to complete one full spin on its axis, thereby defining what we term as a day. In stark contrast, the orbital period is the time a planet takes to make a single complete orbit around its star, termed as a year. For most planetary bodies, the orbit period outlasts the rotational period. The Earth, for instance, takes approximately 24 hours to complete a single rotation on its axis, yet requires 365.25 days to orbit the Sun. This is an evolutionary pattern seen consistently throughout our solar system, with orbits generally outpacing rotation. However, Venus turns this relationship upside down. When we peer into the celestial mechanics of Venus, we find that its rotational period is an astonishing 243 Earth days, the longest in our solar system, to perform a single slow, languid rotation on its axis. In contrast, its orbital period is just 225 Earth days. This means that Venus completes its orbit around the Sun before it completes a single twist of its own. This counterintuitive characteristic begs the question, why? What factors influence such an unorthodox orbit-rotation relationship? Various theories are presented within scientific discourses. One such theory suggests that gravitational interactions with other celestial bodies, notably the Sun, and potentially even Earth through so-called tidal forces, have historically impacted Venus's rotation speed. Additionally, Venus rotates in the opposite direction to most planets, a retrograde rotation, which itself creates intriguing ancillary questions pertaining to its history and evolution. The physics of planetary motion, and perhaps the history of interplanetary collisions or gravitational interplays. This understanding extends beyond theoretical simulations or mere numbers on a page. It provides additional insight